Here we're looking at how we can use the Pythagorean identities that we talked about before to prove further identities. So we're going to look at this one, example 41. We've got to prove that that sec squared theta plus cot squared theta is the same as cosec squared theta plus tan squared theta. I'm going to use these identities to prove it. So when we're doing this with the triple equals thing, then we're going to just work on one side of it, the left-hand side, and try and turn that into the right-hand side. So to do that, we can just first of all take for the sec squared theta, we can say, well, that's equal to 1 plus tan squared theta. And the cot squared theta, if we take this one we've got here, the first one, and we rearrange it, we'll get that cot squared x is equal to cosec squared x minus 1. So because we're working in thetas, this is going to be plus, instead of the cot, it's going to be cosec squared theta minus 1. And we can see that the 1's cancel. So we're just left with tan squared theta plus cosec squared theta, which is obviously just written in a different order, but it's the same as the right-hand side. So we've done it, shown that first one. So looking at B, again, we're going to work on the left-hand side and show that it turns into the right-hand side. So we can use the other identity for cos squared, which is that we've got cos squared theta plus sine squared theta is equal to 1. So that means if we rearrange that, we can say, well, cos squared theta is equal to 1 minus sine squared theta. So I'm going to replace the cos squared theta here by 1 minus sine squared theta. So I get 1 minus sine squared theta cosec theta. And I'm going to multiply that out. So then I'll end up with, if I multiply the bracket by the cosec theta, 1 times cosec theta is just cosec theta. And then it's going to be minus sine squared theta cosec theta. If I now write cosec theta as it is, its identity in terms of sine, so cosec theta is equal to 1 over sine theta. So that means this will turn into the cosec theta we already had, minus sine squared theta times by 1 over sine theta. And since the sine will cancel away the square on that, leaving us with just sine theta, and that's going to be cosec theta minus sine theta. So that was the left-hand side, and it now equals the right-hand side. So we've done it. For this one, C, we've now got to show that cosec theta minus sine theta is equivalent to cos theta cot theta. So we're just going to again work on the left-hand side, try and turn it into the right-hand side. So if we write cosec in terms of sine, then we get cosec theta equals 1 over sine theta. And so we get 1 over sine theta minus sine theta is the left-hand side. And these are a little bit of trial and error. Sometimes you have to mess about with these until it just drops out as to what you want. So you might have go down a few sort of blind alleys or whatever, trying to find what you want. But then eventually, hopefully, you find that you can show that this left-hand side equals the right-hand side. So now what I'm going to do is I'm going to add these two together. If we remember that anything can be written as a fraction over where 1 is the denominator, now we need to make the denominators the same. So I'm going to take the 1 over sine theta, and I'm going to multiply top and bottom of this second fraction by sine theta, and that makes it sine squared theta over sine theta. Now the denominators are the same, and I can add the numerators and keep the denominators as they are. So it's going to be 1 minus sine squared theta over sine theta. And again, if we remember the identity for sine squared and cos squared, got this one. So if we take away cos squared from both sides, then we end up with sine squared theta equals 1 minus cos squared theta. So, and actually that's not the order I really want it in. I'm going to do the opposite. I'm going to take away the sine squared theta there. So I'm going to get cos squared theta equals 1 minus sine squared theta. And that's handy because I can replace the 1 minus sine squared theta there and put it over sine theta. So I'm going to rewrite this 1 minus sine squared theta as cos squared theta. So I'm going to say that's cos squared theta over sine theta. And now what I'm going to do, I'm just going to expand the top line. I'm just going to write it as cos theta, and then so cos squared theta is just cos theta times itself. So I can write it like that. And that's great because we know that cot theta is actually equal to 1 over tan theta, which is cos theta over sine theta. And we've done it. So because we can replace the cos over sine by a cot. So that becomes cos theta cot theta, which equals the right hand side. And that's it.